do a quick part 3 of using Python and gpib to do some logging from an HP3456A. Here's the Python script that I'm using, and I'm going to show you a couple of cool things I did, and we're going to put it into use real quick. I'm going to use this voltage source at 10 volts, and we're going to come over here and start the logging. Sorry for the shaky camera. And one thing I did was I have the log, so it's logging right now, but I have the display dynamically updating on the same line. So you can see logging started, Control C to stop, C3456A underscore test underscore log.txt for data, and then current readings, and then showing the output from the 3456. Over here I have the Keysight I/O monitor, and I'm watching the VISA commands to the gpib interface and then the return values. The /n is interpreted by Python as a new line, and that took me a little bit of playing to get rid of. If we look at the script, while I look at that log, here's a quick description of what I'm doing here. So, starting the logging, I'm using the logging function in Python to generate my log, which I'll show you in a second. So I have to import logging, then do basic config on the logging. And here I'm setting my time format for the log, and including microseconds, 3 decimal places. Milliseconds. Three digits for milliseconds, and then messages, which in this case are going to be the reading output from the 3456, and then I'm formatting the date, 4-digit year, 2-digit month, 2-digit day, separated with a /, then a white space, and then hour, minutes, and seconds. And the seconds is including a dot, which is up here, and 3-digit milliseconds. And this is the file name of the log. I'm going to change this to a variable and add some more things, maybe some user input. It'll prompt you for what you want to call the file name and a few things, but this is just quick and dirty, just to get it working and to show it works. Down here I have to import VISA, define a resource manager, and then a variable for the actual instrument address. In this case, gpib 0, instrument address 22. And then I found if I do really long measurements like 100 NPLC, I had to adjust the VISA default timeout timer, which is set to 2 seconds. So the 100 integration count will take longer than 2 seconds. So I have that commented out right now because I don't need it with just the config I have right now. And then this is where I set my basic instrument configuration. H for reset, 6 ST is store, 6 store, and the G is number of digits. Then down here I'm clearing the screen. I have to import OS. Then OS system, clear screen. This clears the screen down here. Makes it all nice and neat when I start the script. And then I start my loop. I define, right here's where I query the 3456 for V, which is variance, or the display output. That becomes a variable measure, or MES. And then I have to strip the /n. So I'm using this command to strip /n off of the variable MES, which is creating a new variable RED. Then I'm logging RED. That becomes the message up here. And then I'm printing this is where I get my output down here. So number, or #, count, start off count with 1, and then so it prints count starts with 1, and equals, and then reading, and then here is where I'm printing it back on the same line. So end is at the end character, and then flush, so it doesn't have a return, so it just it just keeps printing back on the same line. Flushes and print same line, flushes and print same line. And then here is count plus 1, so it adds 1 every time it goes through the loop. So here's where we see our increment in count and then the displayed value. So I'm going to go ahead and stop this, get on the right screen, Control C, break, and then we can look at the log. There's basically the log, and then we can do something with it. So it's open data plot, and then we're going to load data source, log, open. Yeah, this is really hard to work the computer and get in the screen and to operate at the same time. Kudos to all those guys who do this all the time. So here it starts on line 1, column separate, that looks good. Over here, we're going to make that column 1, date and time format. And then we're going to put a plot in here, curve, data, column 1, plot, boom. Then zero, we'll close that. So here's a basic plot from what I recorded just now from the 3456, looking at 10 volt output from the PDVS 2 voltage source. That simple.